everybody, and welcome to the Aftermath Show number 4. And before I introduce my guest, I'm just going to reply to Aaron in the chat, who said, "This is going to get ridiculous, guaranteed." Absolutely not, Arwin. This is the format. This is inviting a Glober onto this channel to discuss the past 4 shows, and I think you're being very pessimistic about how this is going to go. In any event, the Rumpus, are you there?
Yes, I'm here, Auntie.
Excellent. Nice to see you in. I hope you're feeling a little bit better. I know you've been a bit under the weather recently.
Yeah, been feeling a bit. It's a few things. Yeah, feeling a bit grotty. I'm feeling a bit better today. And thank you for inviting me, Randy. I must admit, this is quite generous, given we've had a few harsh words between one another over the last sort of year or so.
Yeah, our history is it's not been the best. I wouldn't say it's been the worst, but
no, indeed not. I don't think I've been. I hope I've never been horribly personal or anything. I don't believe in being personal, but I do obviously when I believe something is wrong and based on false, poor logic or something, I will obviously be quite emphatic about that. But I hope I don't tend to bring people's character into it very much unless they're really obnoxious, and I don't think I'll put that not in that category.
Yeah, I mean, I'm pretty much the same. I try to just stick to the facts. I try to just try and do presentations. I'm not really into all the drama side of things. I know some people are, and it's not for me though. But this is a new platform, and I think it was on the first week, or maybe it was the second week. I can't remember now. But Tim Osmond did a presentation, and we had it was the Adam Meakin came in for the first round table, and he said, "Oh, is it going to be like this every week? Is it going to be a flat earther in every week?" And I'm like, no. I would like a Glober to come in as well. I mean, this is, if we're going to do a format where we're having presentations from both flat globe and concave, if there's any concavers out there that want to do a presentation, email me, ranty@rantyflatearth.com, and get yourself on the show. But any event, I needed a Glober to come on, and I could think of nobody better than yourself. I mean, you've been around a lot of the people that have done the presentations, so you kind of know how these people are. You know what sort of presentations they've done. I assume you've watched the presentations this week, and
sorry.
Go on. Fire away.
Yes, I did mean to watch more, but as I said, I've been feeling a little bit under the weather, so I missed. I've just watched a little bit of Brenda's, and I've just watched a few minutes worth of the Mr. Brian or whatever it was, Chappie, talking about the Analemma, and I saw the Tim Osmond one, and I saw the Bob Science guy one. So I've seen probably about 75%, and I would have seen more this ones this week. You've picked, unfortunately, the very worst week. I think I've had a worst week I've had for some time. Unfortunately, you picked a bad week for me, but never mind.
No, it's fine. And to be fair, you're welcome back. This isn't just a one-off, I would hope. If there's other Globers that want to do it too, they can email me. I did put the shout out a couple of weeks ago for a Glober to come and join me, and I didn't get a response back at all. And there must be at least 50 or 100 Globers that watch this show. And you'd have thought that one of them would have perhaps wanted to jump on and discuss the week's shows, but they never got in touch with me. So... I've offered the olive branch, so to speak. In any event,
and you won't be having, and I won't be publishing a nasty cartoon of you either, which I think Tim Osmond, was a bit disappointing. He did that.
Yeah, within a few hours of me having of him coming on the show, he did a live stream. And it was Chemburn Ranty and Tim Osmond have a discussion or whatever, and he showing me all. Okay, I can't stop people from trying to break a habit of the past 3 or 4 years, but hopefully this is the first step in trying to have a little bit of a decent dialogue going between.
Yeah, I think so. You ought to be commended on this. Actually, I'm surprised. Actually, Ranty, you were prepared to do this. Actually, given your beliefs, that you were prepared to move into an objective sort of play sort of a neutral role and actually allow people to express themselves. And actually, I think you provided a useful platform here for people to do that.
Yeah, and to be fair, I mean, the whole premise of the show is not only to just put the presentations out, but to ultimately get opposing arguments, but on the same subject, and people that, you know, in some respects would consider themselves to be a bit of a specialist in that particular subject. So obviously, flat Earth is very broad. You have a lot of different inner subjects inside of the topic. So, you know, somebody that knows things about gas pressure, people that know things about gravity, gyroscopes, all that kind of stuff. But to bring in two opposing arguments, or even three opposing arguments if you include the concavers, to literally perform presentations and spell out their case for their argument, and then to actually get into a debate one-on-one, and it might not be the only debate, you know, hopefully this would be a first debate, so that it would sort of like lay the groundworks, and you would obviously realise where your strengths were and where your weaknesses were once you've had this debate with somebody your equal, but from the opposing side. And that would be that. And when you come back again, hopefully there's been time to readjust your research or whatever it is, and hopefully we'll get something sorted out. Because at the minute I just feel like we're going nowhere at the minute. It's like around in a circle, and I'd like to try and get some answers from somewhere.
Well, obviously, I feel I've already got the answers, but it's just a matter of educating those who aren't so. There are a lot of not terribly well educated flatties, I'm afraid, out there, but some of the stuff. I mean, it is interesting the fact that even with flatties, there's the level of the argument, the debate, and the information provided is actually sort of thing you might do at a sort of university level. Certainly, some of the issues we cover are quite deep. Academic issues, so that's quite good. The fact that level of you can have some sort of level of debate like that. So it is educational, and even for us, even for people like me who feel that obviously flatties don't understand, just basically don't understand things. Actually explaining things in a simple way and using all the evidence and the logic that's available to us is actually quite a demanding intellectual exercise, because it's only those people who understand the subject well are able to express it in simple terms, and it does involve quite a bit of research into certainly some of the areas to and things like the refraction stuff, which I get involved in quite a lot. That and the stuff I did work with Philip, that is quite unique actually, as far as I can see. Though on the internet, though there are people like Walter Bislin sort of getting close to that ray tracing stuff. But so anyway, so I don't know which particular video you want to talk about, or something, or any particular subject. Or...
Well, I mean, the culmination, obviously, of these two opposing arguments was literally the first fight night last night with Brenda and Right the Hand. I think you've only seen parts of that.
Unfortunately, yes. I saw a bit about quantum mechanics and electrons and attractive forces and whatever. What was it called again? Like the right hand, whatever it was. He seemed to be confused between the difference between electrostatics and electromagnetics. Didn't seem to know about the four fundamental forces, and seemed to be confused about electrons and electron levels. And Brenda, the bit that I saw, Brenda was giving a reasonably good explanation of why electrons stick to the nuclei and the little bit of quantum wave mechanics, and how you can only get particular energy levels and things. So that bit I caught. So I didn't really hear any of his arguments. So I don't know if you would like to. Well, if it's the key ones that you might like to bring up to me, I could review them.
Well, here's the thing. You see, I mean, I wanted 5 questions from each person, and at least 24 hours before I would have the questions, and I would swap them so that each person would know what questions they were going to be asked. And that would be literally to stick to that subject through each question. And to be fair,
that's good. That's a good plan. Yeah.
They both stuck to the plan very well. So within 36 hours before the show started, I was able to transfer each of the questions, all 5 questions, to the other. And I'll read you out the 5 questions.
Yes, please do that. That would help me a lot. Yes.
So, bearing in mind that this is supposed to be a debate about quantum mechanics, right? So this is the culmination. You know, we've had the flat Earth, and we've had one opposing argument, and we've had another opposing argument, and basically they're now going to get to the nitty gritty of this. I was quite disappointed, I have to say, with Brenda's first question, and you might agree with me on this, I don't know. But her first question was, what is your highest level of education?
Right.
Now, to me, that seems like a wasted question. You know, if you've only got 5 questions to ask, and the idea would be, obviously, if you're going to get into a debate and you're going to take somebody on a journey with you, essentially you would start off with the first question, which would hopefully lead on to question 2, 3, 4, and 5, a culmination where you was able to get a victory in the debate. And I feel that what is your highest level of education was more of an attack on the person and an appeal to authority rather than an actual...
I'll agree with you.
Yeah. Okay, so what did you think about a second question, which was how do transistors work? Do you think that was appropriate, or...?
Well, that's a quantum mechanics issue. I mean, but that's actually very involved. That's all to do with doping semiconductors and the resultant energy levels you create, and you get the energy bands, and then whether or not they can jump across them. And you obviously have the transistors have 3 lines, and you have oh my god, I can remember. You get the collector, an emitter, and you put a small voltage across. The collector, and then that generates a bigger voltage across the emitter. So it's basically a little semiconductor amplifier, which allowed us to reduce the size of things. So it's the actual understanding how that works is sort of undergrad physics. Quite a. I mean, even electrical engineers don't really. Electronics engineers don't go into the detail of how that works. That's a physics issue, and it's. And I remember doing the stuff for that, and the bands. I mean, that was third year physics. Actually understanding how they work properly. I don't know whether she meant how you would use it in a circuit, or how it actually works internally. How does this amplification work? How does putting a small voltage across the collector cause a greater current through the emitter side? There's a simple relationship there. It's just an amplification factor times. It's a current amplification device, but that's if you're an electrical engineer, it might be relevant. Don't quite understand unless she's asking about the. So yes, well, that's a tricky question.
It's a question, but the format is you only get to answer the question, and then if you don't feel that the question was quite answered, so let's suppose I asked you what star sign you were, and you turned around to me and said, I'm born in March. Yeah, and then I went, yeah, but that's your answer. So it's probably likely that you might be Piscean, but we don't know for sure. So it gives you the option then to go into a second question on the same subject and say, look, I don't think you answered it correctly. Can you go back and address that? So the idea would be that you get to ask your question. There's a response. If you don't feel that the person has answered it quite exactly how you want, or they've misrepresented the question in some way, then you can sort of like readjust it slightly, but along the same lines. And then we get into just a 5 minute. We only have 5 minutes about that particular question. So, and it's on a timer. And when your 5 minutes is up, we're on to the next question. So, do you think that how do transistors work and where we could get to in 5 minutes? Do you think that was like? Sort of like, was it too broad of a question?
Well, I mean, I like Brenda, and I think she does explain things well, and so I don't want to pick on it. I'm not the way I mean, I don't know how accurately you're presenting. I mean, I sometimes have some questions about your understanding of what's happened sometimes, but assuming it's an odd question. Certainly, it's not a question I would ask of someone unless they were an electrical engineer or done a physics degree. That's a demanding question. I'm not quite sure what it proves if you're testing someone's understanding of. I mean, perhaps Brenda was trying to. I mean, I don't know who the guy she was talking about to. What was his name again?
Right the hand.
Right the hand. Now, is he claiming to understand quantum mechanics? Now, if she's trying to find out whether or not he understands band theory and semiconductors, and he's made the claim that he understands quantum mechanics, then she's perfectly at liberty to say, okay, then show me you're not talking bollocks. Show me you understand semiconductor electron band theory. So there's a question for you. Now, if he is making that claim, then she's testing, which is quite reasonable to me. But if it's an out of the blue question, then I'm not quite sure. I mean, this debate on quantum mechanics she's obviously saying here's quantum mechanics, and what was he saying? That quantum mechanics doesn't work or something, or he's got a better understanding. I mean, I'm sorry, I've missed that debate.
Well, basically, I mean, he obviously thinks quantum mechanics is a load of rubbish.
Oh, does he? Oh, I didn't know. Okay, so he thinks quantum mechanics is bollocks, right? Okay, well then, in some ways, that is quite a reasonable question then, because he's got to right. So that's not too bad then, because basically Brenda's pointing out that is a quantum mechanical device. It relies on quantum mechanics to work, and if this guy doesn't know that, then she's right to ask him. Here we've got a quantum mechanical device. Do you have some other explanation, or do you have any? Are you in any way familiar with how it works? And presumably, if he doesn't understand, if he denies quantum mechanics, he's then got to come up with his own personal theory of how transistors work. When the rest of the world and science has written millions of pages of academic papers on it and invented the damn thing and understands intimately how it works, and then if he comes along and says no, it doesn't. Quantum mechanics is bollocks. Therefore, he's basically saying transistors won't work. So I think that actually then is a reasonable question from Brenda, because she's obviously identifying he's going to have his own personal explanation of how transistors work, and that not including quantum mechanics. So I think actually now that I see the context, I think that is a much more reasonable question.
Okay, so I'll quickly read out questions 3, 4, and 5 because I don't want to get too bogged down on this. But the third question was, what physical principles explain how fluorescent lights work? Question 4 was, if I use a pressure gauge to measure tyre pressure, have I not changed the pressure in the tyre simply by observing it? And question 5 was, what is a proton? So essentially they were the 5 questions that Brenda was trying to bring to the table to prove quantum mechanics and to obviously get into to win the debate with Right the Hand. Now I'll read you the first question from Right the Hand, andLl do the same obviously. And you can have a think about how he went about tackling this debate for me.
And Brenda had 24 hours to process these questions, did you?
Yes.
Okay, well, I'm sure. I'll see how I get on. Right.
Okay, so what force keeps the electron from flying away from the nucleus, and is there a physical connection between them?
Yeah, well, they have the electrostatic force is the positive and negative charges attract one another. We don't actually know at a very deep level why that happens, but it does, and we understand the equations relating to that, and we can make lots and lots of predictions, and so that keeps the electron revolving around the nucleus because of the attractive force, just like the planets revolve around the sun, or in the same way that you might like to think of spinning a ball around on a above your head on a string, and you spin it round, then the attractive force is replaced by the tension in the string, and that's what keeps it from flying away. There's positive and negative charges, and there's no actual physical thing, but there is an exchange of virtual photons. A photon is a little parcel of light. A virtual photon is a rather special version of a photon that is the exchange particle. And although we've never actually detected these things, they fit in with all the models, and we make predictions with them, and they all work. It's quite complicated, that the exchange mechanism in electromagnetic theory. The electrostatic force, I say, is mediated by a virtual photon, and that is quite an involved process again. But so he asked that question. So no, there's no physical connection, but there are an exchange of these virtual particles.
Okay, so essentially, when you look at question 1 from both sides, it feels to me already like Right the Hand in some respects has already had the upper hand, because it's like he's had a free question.
Okay.
Against, so it's like, he's got 5.
I do agree that Brenda's first question is not a good one, because I've argued with people with PhDs, and I've completely demolished them on issues like fluid mechanics, and there was one it used to be on some forums on Mythbusters, and you keep on finding these pilots and people with several people with PhDs who don't get things right. And so I've particularly come to the point that it's a rule of the internet as far as I'm concerned. I've had this confirmed almost many tens of times. If someone comes forward and leans and starts off with their qualifications and why they're right or wrong, you invariably catch them out, and they get caught out and they're wrong. So I never bother with working out what qualifications are. I always go with what the quality of their argument. And very quickly you find, and that same thing, I mean, people that Philip will have an interaction with, he, for instance, an example where immediately I speak to him, I can see he's a very intelligent chap, and then you find out he's doing a PhD. And that's the way it should work. You don't need to throw your qualifications at people to make a good argument. It's the quality of the argument that counts. So anyway, who cares what the who? I don't really care who got a free question or not. It's the quality of the questions that matter.
Yeah.
So that's the answer to. I've forgotten his name again. The right chappie. Question
right
is the hand. I'm trying to make him remember that. Right. So that's the answer to the first right hand question. Okay.
Okay.
So what does he? Karen.
So question 2 would have been. By the way, I fully agree about qualifications and stuff. Just because you have letters after your name or you've gone and got a full degree doesn't mean that you're an expert in anything. Essentially, it just means that you've been able to regurgitate stuff.
Well,
that's the way I feel.
It's usually more than that. So if you've done a physics degree, you've had to do quite a lot to get that. But you've had to learn quite a lot and understand and be able to do things. But electrical, a lot of the physical hard sciences, you've had to do quite a lot. But even someone who's done an arts degree, I mean, Brenda's an example. She has not done a science degree, but she speaks intelligently, and she gets a lot of things right, and does really well given the fact.
Okay, so question 2 was, what does an atom look like if we have never seen one, and how do we know that's what it looks like?
Well, we've effectively said we can bounce X-rays and things off atoms and find out their separation. And there's a very famous, and I could go and find. There's a very famous video on YouTube, I think, where the little IBM placed, I think it's carbon monoxide molecules on a copper plate and actually moved them around and had it playing football. And these are images that are being gathered from electron, is it tunneling electron microscope or something? So I mean, but then when we say we've seen something, the normal light can't get is too lower frequency. So we could never see an atom, no matter how much because it doesn't. Normal conventional light will not illuminate it. You have to use electrons effectively using. In fact, actually, there's an example of quantum mechanics at work. The wave-like behavior of electrons has a higher. The wavelength of an electron is actually shorter than that of light, and you need to have the wave that you're using to detect things to be of a similar frequency or similar wavelength as the thing you're trying to look at. And unfortunately, light is just too big. You can't see atoms with it. So you have to use things like electrons and using the quantum wave-like properties of it to see it. So yes, we do have pictures in effect of atoms, and if you just made a cursory inspection of YouTube, you would find some fantastic videos. And in fact, I think I saw something on New Scientist recently where they were actually showing the electron levels. The video that I'm talking about on YouTube, the IBM one, just shows the outer shell of the atoms, because the only thing you can see of them is the outer electron shell. You can't see nucleus with this, nucleus being a factor of 1,000 smaller than the atom. But you can see the outside shell, and now I've seen something else showing the individual shells of electrons now. But anyway, he's obviously not bothered to even do the most simple bit of research if he's not aware that we do have images gathered from electron microscope work on YouTube. So that's a rather poor question from him.
Okay, so I'll just read through the last 3 questions. Is there a vacuum of nothingness between the electron and the nucleus? What are the electrons?
Well, they're full of virtual particles. Other than that, probably, but yes, there's nothing in there. Sorry, I've interrupted. Karen, sorry.
Question 4 was, what are electrons made of, and how does combining them in different formations result in different composition of matter? And question 5.
Well, they don't combine. Okay, well, electrons are the smallest. They're a point particle. That means we have no means of measuring their size. They're so small. They effectively are points. We cannot determine the size of an electron. They're that small. There's nothing we can do to determine their size. They're that tiny, and they don't combine except they share. They don't combine as such. They do share electron shells, and they have spin, and they two electrons in opposite spin can occupy the same electron level, but due to Pauli's exclusion principle, they then can't occupy. They can only have 2 electrons in any one level. And interestingly, if anybody saw, for instance, the Brian Cox video, fantastic lecture he gave on BBC with a diamond, and he went into great detail about the space, that atoms are mostly space. The fact that for instance, if you if you want, I think, what's the example? If you think of the nucleus and the electron of a hydrogen atom, for instance, with just one electron, I think it's something like something like a football stadium, even an American or British one I would do. And the nucleus, if you think of that as the stadium being the orbit of the electron, the nucleus would only be the size of a pea in the middle, and that would be the relative sizes. And so electrons don't combine. And I was going to make some other very interesting point about. Oh, that was it. Then in due to Pauli's exclusion principle, you cannot have electrons in the same energy level, and due to this, in fact, this is another quantum mechanics issue. They cannot share any states. There is no other electron in the entire universe that can share the same electron state. So if you actually give an electron, you change its state to another state, or if you have an entangled electrons and you take the other electron to the other side of the universe, and then you fiddle with the other one of the electrons that are entangled with an electron you sent over to the side of the universe, it will instantaneously change its state. Now, this is a rather Einstein didn't accept this understanding of this immediate effect, this Bell inequality thing, or this ability to not transmitting information, but at least causing things across the size of the universe. It's probably getting a bit involved here, but Brian Cox, I don't know if it's on the YouTube, but they should look at Brian Cox giving a lecture about quantum mechanics with Jonathan Ross, I think, was there as well, and it's an excellent introduction into quantum mechanics and the fact that most of an atom is space.
Okay, question 5 was, do you agree that everything you think an atom is would be based on an interference pattern on a graphite medium?
A what medium?
A graphite medium.
No, that's utter bollocks. I don't know where. Is that something he's obviously just made that up? Obviously something he read, had a dream about. No, utter drivel. I mean, it's just he has no evidence for this. This is against science. Has no interest in this. I mean, people are professional scientists. I mean, what I don't think people like this. What's his face again? I forgot the stupid name again. Something about his name. I don't know. Write the hand. Right, goddamn, I don't know why I can't remember that name. There are institutions and millions of people who do research on this, who check one another's homework. They check one another's experiments. And if anybody came with some random theory, it'd be shot to pieces. But everybody loves to come up with their own pet theory. I mean, Einstein, for instance, when he came out with this theory, he was shot to pieces initially, but he stuck with it and he made predictions with it, and finally his theories were accepted. Every scientist would love to invalidate not existing science is rather difficult because that's been validated, or at least find some problems with it or add to it. So everybody's looking to try and invalidate the orthodoxy, and so I think these people like this Write the Hand think that the science isn't self-critical, isn't trying to pull itself to pieces all the time. It is all the time. There are people out there trying to make that breakthrough, trying to become the next Einstein, and they're all being checked by one another, and if they start talking bollocks, they get shot down. So anything that does manage to make it through into the literature as something that's been verified by hundreds of thousands of people, probably had thousands of experiments related to it, and been validated, and as well as thousands of institutions. So there's a self-checking peer review mechanism that makes sure this stuff is correct. So in fact, he's made up something, would be shot to pieces.
Well, essentially, they were the 5 questions. I think the entire show took about an hour and a half, so we had a 15-minute debate at the end once all the questions had been asked, and they'd had the 5 minutes on each question. And it was quite an interesting. I felt it was quite interesting anyway. There was a point at the end where it seemed that at any point both were ready to rage quit at different times. And I think it's got to that point because I don't know whether it was the questions or the way it was led or anything like that, but essentially, we didn't really get much progress, I have to say. It's like a bit of a stalemate. So, well,
unfortunately, the questions that Write the Hand were asking, those are involved questions that only people with physics degrees can really answer. And so as I said, not familiar with what Brenda said. The bit that I did hear, she got correct about the electrostatic forces. She gave the correct answer for the force between protons and electrons. Now, what more can she do? She's basing it on the body of science, which has been validated, peer-reviewed, proved as much as you can prove anything in science. What more can she do if this guy is not prepared to accept? I mean, he would not understand if we went into the quantum mechanical. I don't suppose he understands the Schrödinger equation, for instance, which is the basic equation that determines how particles behave according to quantum mechanics, how they jump around, leap around, how they have these probability densities. He probably doesn't understand any of this stuff. This guy is clearly ignorant. Now, if he's ignorant, his ignorance is like a shield. How can you convince something who doesn't understand logic and science and evidence and reason of something if they're immune? If they don't understand the basic science, it's very difficult to explain. You've got to go back to take him back to when he's 13 and start educating him in basic physics, and then you've got to get him to doing some GCSEs, and then you've got to get him to A levels. Then finally, you've got to get him into university and say, right now, do you understand what the Schrödinger equation is? And then yes, I do. And do you understand this being proved experimentally? Yes, he would. But unfortunately, his ignorance he's using as a weapon by saying, I don't understand that, and because he doesn't understand something, he's presumably saying he doesn't accept it. He doesn't accept also the peer review process. So unfortunately, with idiots, it's very difficult to convince them of something if they don't understand. They're so far behind in their understanding and their knowledge and their ability to reason that it's very difficult to reach down and pull them up into the body of human knowledge that we've got. And so presumably from his point of view, he didn't understand what Brenda said to him, and therefore he assumed that she was wrong. Unfortunately, it didn't occur to him that it's simply his lack of education and idiocy that's responsible for his problem. And Brenda presumably was frustrated, thinking, here's the guy, an idiot. I'm presenting him evidence that's supported by institutions and people who are very intelligent around the world. I mean, I'm an idiot in comparison to the people who are doing this stuff that I'm relying on, who are publishing books. I don't understand half of them. Well, not even a tenth of what's going on in quantum mechanics. As Feynman himself famously said, if you think you understand quantum mechanics, you don't understand quantum mechanics. And he said he was intelligent enough to know how stupid he was. And this is Feynman, the guy who writes the books. No one human being can understand. When one of my physics lecturers said to me, we probably know about 2 or 3 or 4% of what's to be known. So, these are intelligent people who, if you met them, and I've met a lot of intelligent people, I feel absolutely stupid in comparison. I've been absolutely thinking, God, I've got a genius in front of me. I'm an idiot. And then the world is full of these intelligent people. And unfortunately, and they're the people who discover things, and then they disperse this information. Then poor people like Wright the Hand, unfortunately, are just not capable of picking this up.
Okay.
So was I overdoing that?
Matt, I believe you're doing a presentation next week at some point, and if we ever get to a point where we have a debate, I think we're going to have to increase the 5-minute limit to about a 30-minute limit, just to allow you to have your say.
Well, that was a more general rant, I suppose. I wouldn't. When I'm focused on a particular subject, I can home in on it and stick to it. But you were inviting me, I think, you asked me a broad question about why you didn't get anywhere, and I had to then go into quite a lot of detail as to why an idiot doesn't accept an argument.
Okay, well, I mean, like I say, I thought it was a good debate. I think there's room for improvement in their arguments. I'd love to have them back again to have a second crack of the whip. And I believe your presentation is going to be on the atmosphere or something, was it? Or the... Yes,
I thought I'd tackle this. This seems to be the favourite subject. It mixes up gravity, this container business, second law of thermodynamics, entropy, vacuum, going up into space. There's a whole wad of issues there, and if I can demonstrate both experimentally and in theory why the atmosphere is where it is, why there's a pressure gradient, why there's a vacuum out there, why the atmosphere doesn't disappear, what's the force that's holding it onto the Earth, and that whole broad span, then I thought that might cover a few areas and invalidate obviously some of the idiocy that's being spread by people who are unfortunately either willfully stupid or non-willfully stupid and don't understand the simple issues.
Okay, so did you happen to get did you actually watch Bob the Science Guy's presentation, Does the Earth Rotate? What did you think of that?
Yes. I thought he did a good job, yes. And, that's right, and the QE QE did an analysis of it, I saw as well. And for instance, he got confused he went to Bob Bassar's he went to great lengths saying how, for instance, a gyro compass works, that it is based upon a precession inside the gyro compass and has nothing to do with a magnetic thing. And then poor old QE comes on and says, but look, they align it with the magnetic pole, and therefore it is a magnetic base. No, it's not. They just make sure that it's working correctly by measuring it against. Comparing against what a magnetic compass says, and what's more, they then orientate it to begin with, because it's got to align itself. It takes some time to get into aligning itself with the rotation, and so they started off pointing in they're sort of close to the right way, because it's going to reorientate itself over time, and it takes a little bit of time to get going. So poor old QE just heard there was a magnetic compass involved in it, and therefore thought it's had something to do with magnetism. Absolutely not. It's just a checking mechanism. And obviously you've got to make sure the equipment's working, and occasionally you're going to check it against the magnetic compass. The other points that Bob Sartsky made, he pointed out the 24-hour thing on the Antarctica. What else did he say? I can't remember if he mentioned the Coriolis force. Did he mention the Doppler effect? No, he didn't mention Doppler effect on stars. Did he? Did he mention it? Oh, that's right. He mentioned also the gyroscopes and the spinning of gyroscopes, which even Bob Nodal unfortunately found to his cost when he actually got one of those fiber optic gyroscopes. Actually showed that it was rotating, and then he somehow had to decided to rediscover the ether that has been abolished a century ago, to try and eliminate the unfortunate facts. And obviously this idiotic claim that mechanical gyroscopes would show exactly the same thing, but of course when people make mechanical gyroscopes in their bedroom using completely unsuitable equipment, they don't end up with the results, and that's what he was comparing it against. If you make a gyroscope properly, it will get exactly the same results as the fiber optic gyroscope that Bob Nodal used, but unfortunately, we got some flatties who can barely screw two things together. They basically put a shelf together, trying to make a gyroscope, and then it doesn't work. What a surprise! And they don't want it to work. If you don't want something to work, then it's not going to work. Particularly, and even if they did want it to work, they wouldn't be capable of making it work. So, who cares whether they can get the mechanical gyroscope to work? I can't remember the other points that Bob made. It was quite a good video presentation he made. What were the other points he made? Could you remind me of the points he made?
Well, what do you think about the consensus among the majority of flat earthers that a lot of the arguments that he brought up were essentially from 2015 and had already been debunked many times over? What would you say to that?
Well, you'd have to remind me of what. Just give me an example.
Just his entire, basically the whole presentation. The whole presentation.
It was all everything he said was correct. So, I mean, if you want to give me an example of one that they think that was debunked, I mean, just remind me. The fiber optic gyroscope, that's been shown. I mean, if you get a fiber optic gyroscope, it will demonstrate a 15-degree change per hour. So that's an established fact. This is used by the error called the drift. I mean, this is an established fact. This is what people use. So this is used every day, the drift on gyroscopes. It's not like this is some sort of theoretical thing. It has to be built into what things use. Fiber optic gyroscopes use this. This is how they work out. It's used every day. I can't remember what other arguments he. You have to remind me what the arguments he offered that were supposedly invalidated.
Well, just off the top of my head, I can think of one point, for instance, that the two reference frames were avoided like the plague. What for
Coriolis or something?
So if you had a helicopter hovering in one place, you could literally just hover there.
You can't. And let Okay, well, this is just idiocy of a grand scale. I mean, this is idiocy of a scale that I just find incredible that flatties don't understand. When you're on a train and you jump up in the air, do you expect to come down where you leapt off? Yes, of course. Can you pour yourself a drink? Yes, of course. So why would you expect a helicopter, when it raises itself up, which will have say it does it at the equator, it's moving at 1,000 miles an hour. Let's do the equivalent in a train. If a train is going along at 1,000 miles an hour and you jumped up, you would come down exactly the spot below the spot you left. Similarly with a helicopter, it's moving at 1,000 miles an hour. It doesn't stop. Imagine if it's moving at 1,000 miles an hour, like that. You are on a train going 1,000 miles an hour. Now, when it goes upwards, it's still got that momentum. It's not going to go in it. Imagine what is going to stop it from carrying on moving at 1,000 miles an hour? Nothing. It would have to. it's going to carry on with that 1,000 miles an hour. And there's nothing, because the atmosphere also rotates with the Earth, then it's going to carry on. So, I mean, this is extraordinary. It's as though people have never been on trains or aeroplanes. That if there's an effect that they're thinking about, that if you're moving on something, you jump up, they surely should be making the same argument. When you go along at 500 miles an hour in an aeroplane, and you pour yourself a drink, then, oh dear, that drink has poured yourself a cup of tea. Oh dear, suddenly that's left the 500 miles an hour. Then why it should shoot you in the face? No, it has this. It's got the velocity of the aeroplane. It's picked that up, and just as you have, and so for the same reason, you can pour yourself a drink on an aeroplane at 500 miles an hour. A helicopter is not going to suddenly shoot backwards either. Just because it's in mid-air, simply with your drink. When you're pouring it in your drink on an aeroplane at 500 miles an hour, that's no longer attached to the aeroplane, but it still goes into your cup without you having a problem at all. And if you throw something, you decide to do some juggling on an aeroplane. Similarly, the balls don't suddenly bash you in the face because they've left your arm. They start off with that 500 miles an hour in your hand and going towards wherever the aeroplane's going, and they're not going to lose that because there's no the air's moving as well, so there's nothing to stop the brake. You'd have to put brakes on the damn things, and the only thing you can have there is the atmosphere, and that's moving along with the helicopter or in the aeroplane as a capsule in the aeroplane. Obviously, if you did that outside the aeroplane, you have the great wind coming at you, but not, you're in the aeroplane. So if anybody makes that argument, they don't understand that pouring a cup of tea in an aeroplane would invalidate their entire argument. I cannot understand how people can make such a stupid argument. It really is the lowest of the low, that one.
Well, how many reference frames are needed for the Coriolis effect?
2.
So,
and this is another thing people don't understand. If there was no atmosphere, the Coriolis effect would still exist. I mean, Nathan, for instance, somehow seems to think, doesn't understand, well, he doesn't understand reference, well, he understands very little. He doesn't understand, for instance, that if you start walking on the surface of the Earth, you are on a different reference frame. Reference frames, I mean, I just find this incredible. This guy goes on about reference frames and understands nothing about it. A reference frame, you're in a reference frame if you do not have any velocity with relation to the reference frame. If you start moving with relation to the reference frame, you're in another reference frame. So if I start walking along the surface of the Earth, I am in a different reference frame to the surface of the Earth. If a train starts to move at a speed, it's in a different reference frame to the Earth. Now, so with a and also Nathan gets mixed up between the Coriolis force and just relative velocity. He hasn't even started on the issue of relative velocity. He doesn't understand that a walking person is in a different reference frame. And the Coriolis thing is another issue. And people don't understand how mild the Coriolis force is. So, for instance, on a sniper bullet firing over, say, 2 miles, it causes a deviation of about 13 inches. When people then say, well, hold on, why doesn't an aeroplane get subjected? It does. But the forces involved in the Coriolis effect are less than a little breeze, less than a little waft of air. So this idea that the poor pilot in an aeroplane is fighting against the Coriolis force, he's having to fight much more against a little waft of air. It's only things that go over very long distances, like 1,000 miles, that's like as in weather systems, that get affected gradually and very, very slowly. I mean, Nathan is just, to not understand the most basic elements of a reference frame and then feel he's qualified to talk about Coriolis when he doesn't even understand what relative velocity is. Now, he won't understand, of course, that if I were to ask him, like all flatties, they can never quantify anything. All they can do is say, well, this sort of does that sort of. They've been qualitatively. Well, for a start, he doesn't understand the number of reference frames involved. He doesn't understand there's no atmosphere needed. He thinks the atmosphere, for instance, by entering the atmosphere, as he puts it, you're entering a reference frame. No, it's got nothing to do with being attached to something. As I say, you could be, when you're walking, you're in a different reference frame. And he doesn't know the formulas for the Coriolis effect. He wouldn't be able to tell you what the Coriolis force was or what effect it would have over a particular distance because he doesn't understand any of it. He's an utter moron. And when someone thinks, this is Dunning-Kruger writ large, when they think they could talk about reference frames and they don't understand that just walking on the surface of the Earth puts you in a different reference frame. They think, because you're touching the Earth, that means you're in the same reference frame. This is a level of idiocy that, it's so stupid. You have to wonder whether he realises he's that stupid. But then again, it's such a stupid thing to say that you have to think that he is that stupid, because someone who knew they were talking bollocks wouldn't say it because it's so obviously stupid. So he must be obviously stupid, I think. Or perhaps he just, I don't know, for financial remuneration. I know the QE is just as bad, of course. He doesn't understand relative velocity. He doesn't. He had the same issue with the helicopter thing. I mean, he obviously doesn't believe that pouring a cup of tea or whatever in an aeroplane works, and he doesn't understand the difference between elevation and drop. I mean, these guys talk about drop and elevation, and they don't understand the difference. And that they thought that the model of the Google Earth was a model of flat Earth because they looked at the elevation data, not and then thought that was with the drop data, and not realizing that there's a distance from this. It's the elevation data given in Google Earth is relative to this geoid, this conceptual surface, which is sort of related to the centre of the Earth, which I could go into. I've got some diagrams if you wanted me to go into detail about it, but I've rather wandered off anyway. So perhaps you want to help me and. Was there any other? So we were talking about Bob the Science Guy, weren't we?
So we have a question. Well, not a question, but just basically a statement in chat from your favourite flat earther Nathan Oakley, who says,
"Oh God." So
walkers drift, planes don't. Okay.
Well, when you are attached to the Earth, well, you obviously you've got grip on the Earth, so you can correct anything. Just like you can correct yourself from a breeze, you can carry going in the direction you want to go. As I say, the Coriolis effect for something moving so slowly, the Coriolis force is related to your velocity. So going slowly means the Coriolis force is next to nothing. Similarly, as I say, even for an aeroplane, it's only a very slight breeze, and not even a breeze. So you can walk in a very slight breeze, can't you? And you've got the force of your feet. So it's absolutely irrelevant. Sorry, what was the other part of the question? There was another bit to it. There's something about. Sorry, could you remember what the second half of that question was?
Right, hang on, let me just find it again. So walkers drift and planes don't.
Yes, planes do, but again, they're being totally corrected. An aeroplane has to deal with winds. The dealing with winds is much more of a serious problem to aeroplanes than Coriolis. As I say, it's equivalent to the waftiest waft of something, and that affects bullets and things over a distance of 2 miles. So, I mean, it's just extraordinary that this again just demonstrates he knows nothing about the subject.
So you see, like I say, I mean, this is it's a controversial subject for flat earthers because, obviously the premise is here that there is no spin, there's no rotation, and trying to define what can be classed as moving due to the Coriolis effect.
Do you want me to give you a list of reasons to what evidence for why we're spinning?
Well, no, I'd rather keep it more to this Bob the Science Guy's presentation.
Well, it was
which was like I say. I mean, from the flat earthers' standpoint, a lot of the stuff that was talked about, from the flat earthers' side was essentially it's been debunked. 2015.
Well, exactly. So far, you've brought up the helicopter, and I've already demonstrated that was silly. So what other points did he make that supposedly been debunked?
Well, the aftermath show is basically just a broad roundup of the presentation, basically.
Well, I say, unfortunately, I've forgotten the exact details. If you give me a prompt on what he'd said, I could remember that. I did see it, and if you just give me a quick prompt on the points that he made, I could summarise
it's just basically the entirety of the presentation. But
you have to give me some points.
All I'm saying is,
you keep on saying that, but you don't give me. I work on specifics, and we've made up one specific about the helicopter, which I've demonstrated is utter ridiculous. There was another one about the fibre optic gyroscope you brought up, which I've demonstrated is true, and even Bob Nodal has evidence to support that. So, I mean, surely you want to deal with specifics and not generalities, Runty.
Well, it's a general chat. It's not supposed to be a specific about anything too much. It's basically a broad recap of the
issue
show.
Is he brought in the presentation. He brought up, I don't know, 5. I can't remember. It's 5 or 6 claims, and you're saying that these 5 or 6 claims were refuted. Surely that's the subject at hand here, isn't it?
Well, no. What I'm saying is that broadly speaking, the flat earthers are saying that the arguments put forth.
Right. So we need to know we need to discuss what the arguments are.
Yeah, but
so we can't just. So if you just say
the whole thing about this format is that I try to stay as impartial as I can.
Yeah, but you can tell me what they've said. You can tell me. I mean, if you just say to me, if you say to me the flatties refuted what he said and not tell me what they said or what he said, then all I can say is, well, they're wrong, and then that's not much of a. No, we're not going to chat very much about that.
Okay, so what did you think about because Quantum Eraser did a presentation against Bob the Science Guy's presentation. What the points that he brought up? What did you think of that?
Well, he's an quantum eraser is the idiot's idiot, isn't he? I mean, he just thinks that if he shouts loud. I mean, this is a guy, as I said, who thought that the elevation data in the Google Earth was related to drop, as did Nathan Oakley. I mean, that is just extraordinary to get that confused. I mean, I could show a diagram of what drop. Yes. I mean, if we're dealing with QE, I think did he cover the subject of drop? Let me just show you a diagram of what drop is and what elevation is. Let me show you this, because that seems to be. It seems to me we need to understand what they are and why the Google Earth doesn't. Actually, while I've got this, I might show this. Actually, let me share this screen. Whoops, I got a mistake there. Stop that. Right. Well, I suppose let me just. I could go into this. Let me just talk about drop first. Where's my drop? Where's this drop business? Right, here we go. Right, so this. Can you see this?
I can, yeah.
Right, so this is a drop. This is so here we have an observer, and this is obviously and drop. Remember, always involves being at ground level. Anybody who starts talking about drop and they don't include and they talk about then observe and they're talking about an observer who's not at ground level, then that's not relevant. You need to talk about hidden. But when you're on the surface, then you can talk about drop. And here we see what drop is. And here, for instance, this building here is this far away, and this is the drop. There are two sorts of drop actually. There's the drop going along the radial from the centre of the Earth, and the drop relative to this. So this horizontal line here is the observer's horizontal, and the base of the surface of the Earth is the drop. Now, that's got absolutely nothing to do with the elevation data, because of course, have I got up here somewhere? And this is this document I one day will be doing. I've got, unfortunately, my life become a bit complicated. I've been a bit distracted the last few months, that's why I haven't finished this thing of antonyms. So there, for instance, this is obviously the Earth here. I mean, I don't even think that Nathan and QE understand what up and down are, for goodness sake. So here's a model of the Earth, and up is, well, down is pointing to the centre of the Earth, up is pointing away from the Earth, and obviously these points now, this is just an approximation. This is not the elevation mentioned in Google Earth, but approximately the surface of the Earth here is the distance to the centre of the Earth. But in fact, accurately, the actual value given in Google Earth is not the distance from the centre of the Earth, but the surface. This is something else that QE did a presentation on, but actually must be not Bob Sarnsky. I think he was doing one against me and Toady, I think. So yes, I might be wandering off here a bit. But it's a good thing to understand. Oh, come on, scroll down, you bastard. Oh, come on. It doesn't get slow when it's when I'm being screen grabbing. That diagram I was just showing you just now. Come on. Oh, Jesus Christ. Hold on a second. Here we go. Right, so this diagram here, which QE didn't understand, of course, because he's an idiot, we have, because defining elevation is actually quite a tricky subject. You could say, well, here's the sort of mountainous range here. You could say, well, here's what's called the topographic surface on the top of this mountain. How far, what's my elevation? Now, you could say, well, okay, I'll make it to the relative to the sea level. Now that actually changes actually in terms across the Earth, currents and things. And in fact, actually being next to a mountain due to the gravitational attraction will mean that in fact, around the base of a big mountain, for instance, that the water will actually have an increased height. In fact, this was the mechanism, the prior to the Cavendish experiment that was suggested of actually measuring the deflection of a large pendulum near a mountain in Scotland. They found a very symmetrically shaped mountain, and they thought, if we see how this deflects from the vertical, when we're near this mountain, we can get a measurement of the gravitational attraction between mass and determined. They didn't call it big G at the time, but the constant that relates the universal law of gravitation. And so that actually causes the sea levels change, as well as currents do, as well as things like the different density of the salt water. So what we have done has created something called the ellipsoid or spheroid, or the WGS84 surface. And I've drawn this in this pink dotted line here. And that's a mathematical idea of where zero is. And that does not necessarily coincide with where sea level is. As I say, that can vary due to local conditions, tides, goodness knows what. So you can't even use sea level properly. So we had to invent this idea of where the zero was, and that's called the WGS84 with some modifications. There's a gravitational modification to that, which gives you which Google Earth uses. So when it goes in Google Earth, it says, right, what is the height of some point on this mountain or something relative to this theoretical surface of the Earth, which does not necessarily match sea level. And that gives you your elevation. And so when we talk about elevation, that's the thing that Google Earth gives you, the distance between this dotted line I've got here, which is the ellipsoid spheroid surface, and wherever you are.
Could I just ask a question? Nathan's getting very animated in the side chat here, saying that essentially this is not where Google get their elevation. Would you agree?
Well, they do. They measure in Google Earth. They use the scan, whatever it was, the data from the shuttle orbiting mission data that bounces radar beams off the topographic surface, and they then find the latitude and longitude of that point, and then they say, how does that differ between the WGS84 surface? They put that in the elevation. So that's very similar to it's related to the distance to the centre of the Earth, but it's not. It's more complicated because this surface is a mathematical surface. But that's what the elevation data you get in Google Earth is from wherever you are, the point of longitude and latitude, down to the WGS84 ellipsoid spheroid. That is the value it gives you, and that's what it shows you in that pink rectangle or whatever. The area in Google Earth when you bring up the elevation data. It brings up the point on the surface, on the topographical surface above the WGS84 geoid spheroid thing. That is what it does. So Nathan, as usual, doesn't understand what he's talking about. He doesn't understand what an ellipsoid spheroid. I mean, let's not forget, this is the guy who was following on, who thought that he doesn't understand how to convert between kilometers and meters, and thought that the WH84 was crushed because it mentioned the ratio of the 1/300 or 1/298. The fact that the North Pole the Blake spheroid is slightly bulging at the equators. He then thought, because there was this factor, he got utterly confused and brought, who's the guy, Chris, or whatever he was named, the Chris guy, confused him completely, and he just took it on board, and then he gave up on that shortly afterwards after being shown a complete idiot. So he doesn't understand any of this. So the fact that he doesn't understand what the elevation data means doesn't surprise me at all.
Anyway, we've certainly drifted from where I was...
Well, you asked me about what QE, because QE didn't understand this either, so that's how we got onto that. And you didn't understand drop. Yes, QE. I can't remember what. Besides QE getting, yes, he didn't understand the. He made the helicopter point you made earlier, which is, as I say, just try and pour yourself a cup of tea on an aeroplane, and then you should realise that QE is talking bollocks about that. And then he also used the Google Earth thing. That's why I brought up the elevation thing. He then said, here we've got 2 points at the same elevation, he'd have a point several thousand miles apart, and Google Earth and say, look, they're the two things. What about the drop? Google Earth doesn't mention drop at all. It's not in Google Earth. They only show elevation.
Well, could you explain to me this cup of tea in a plane? Because I don't think I've heard that before.
Well, okay. Well, look, the idea is that, okay, let's or juggling or
no, let's do the cup of tea. Let's do the cup of tea.
Okay, cup of tea. Right. So when you're going along in an aeroplane doing 500 miles an hour, and you pour out a cup of tea, there is a point when the liquid that's coming out of the pot is not attached to anything, and yet it still managed to get from the thing you're pouring out, which was travelling at 500 miles an hour, and drops into your teacup that's also travelling at 500 miles an hour, along with you and the aeroplane that's travelling at 500 miles an hour, and it doesn't just suddenly shoot into your face, it drops as though you were stationary. And this is called the Galilean reference frame. You can't tell, if you're going along at constant velocity, whether you're stationary, whether you're doing 500 miles an hour, 2,000 miles an hour, or 1 million miles an hour. You would not make any difference to your ability to pour a cup of tea or to juggle. And so similarly with a helicopter that leaves the surface of the Earth, it starts off with a velocity of 1,000 miles an hour odd at the equator, and it retains that velocity. It'd have to find some way of braking itself. So the fact that people like QE think that because a helicopter leaves the surface of the Earth, it loses that 1,000 miles an hour, it doesn't. Just like the tea that's being poured out of your teapot doesn't lose the 500 miles an hour. If it lost the 500 miles an hour as it poured out of the cup, it would then go into your face at 500 miles. You'd have a 500 miles an hour face full of tea. So the same reason that you don't get a 500 miles an hour face full of tea, the same reason that the helicopter just leaves the surface of the Earth and does not lose the 1,000 miles an hour that it had when it was touching the surface of the Earth. It's still got the momentum that it had before. No one's put a brake on it. To change your velocity, as people should know from force is equal to mass times acceleration, Newton's second law, to change your velocity, you need to apply a force. Where's this force come from to slow it down from the 1,000 miles an hour? You need to apply a force. And it hasn't applied a force. It hasn't, if it just goes straight up, it's not applying a force to increase or decrease its horizontal velocity. The wind, the atmosphere, let's assume it's a windless day. The atmosphere is moving along also at 1,000 miles an hour on the surface of the Earth. So everything's moving along at 1,000 miles an hour. There's no force to stop the helicopter. So as it rises up, it still retains the 1,000 miles an hour that it had. And that's why if it then, on an aeroplane journey, similarly, it takes exactly the same distance to go east or west for an aeroplane. For the same reason, it takes you exactly the same time on an aeroplane to go 100 meters, to walk 100 meters towards the cabin of an aeroplane, or 100 meters back, or on a train. It's no more difficult. Following the Galilean point, you can't tell in a constant velocity environment whether you're moving or stationary. It's no more effort to go to the back of the train or the front of the train. It takes you exactly the same force on your part. You do not need to worry. Similarly, with a helicopter on the Earth, it's just as easy to go along with the surface of the Earth velocity or the other way. Just like being on a train. It's exactly like being on a train. So anybody's been on a train and then thought, oh, look, it's exactly equally easy to walk up the aisle or down the aisle. It makes no difference. And I can pour a cup of tea and I can juggle. It's as though I'm stationary. Similarly in a train, because you can't tell me, if you were to blank out the windows and had perfect suspension, you would not be able to do a single test. There is no test that you could do in that train to work out that you're moving. If you managed to remove all the the jiggliness of the rails, if they were perfect, there's nothing in that environment that you could do to work out that you were traveling at 1 million miles an hour or you were stationary. That was what Galileo discovered in 1610 or so. And the fact that people haven't caught up on this, which is something they should have understood when they're about 13, like some flatties, just means that they've missed out a great wad of their science education, and they need to go back to being 13 and educated. They need to go back to school. I mean, it's really bad. It's a horrible indictment of our education system.
Hey, you've stopped. Right, okay.
Sorry.
Right, okay. Listen, I have a question. From the Plain Truth. Ask the Rumpus, at what altitude a copter will lose the velocity it had at ground level. So ask her...
It never does.
Oh, it never does? Right, okay.
No,
so
if it goes up,
the velocity.
It will carry. Yes, if there's no wind, let's assume there's no wind, and there is an issue. There is an issue that the surface of the Earth, that the atmosphere, although I've said before, it's sorry to simplify it for simpletons like Nathan, there is actually a slight velocity gradient as you go up, because just like a car, a wheel of a car. As you go up from the hub of the car, of a car's wheel, as you go up, it actually increases in velocity. And so if you were to remain the same position, you would have to go around fast. But of course, something that's just going straight up is not. So that means that if you do go up, so for instance, if you were to shoot a bullet up into the air, vertical, it does not come back down where it came from, even on a windless day. And similarly dropping, for instance, if you were to drop something off the Eiffel Tower, this is, by the way, one of the reasons we know that we were rotating. If you're in a tower for instance, there are tall towers with vacuums in them. If you just drop something, it will not fall vertically down from where it is, because the velocity higher up is on a solid feature that's attached to the Earth will be higher. And so the atmosphere actually has a very slight gradient. I think at the top of the atmosphere, it's moving at something like 30 kilometers per hour less than the surface of the Earth, because there is this velocity gradient. So if a helicopter that went up vertically, like a bullet that was shot up, just like a car tire has to go faster at the edges to keep up with the hub. The helicopter would actually lose track of its vertical position as it went higher and higher, just like a bullet does, and doesn't come back down the same spot for the same reason. And I'm probably adding in more detail here than this poor plain truth's probably brain can cope with. But fundamentally, it doesn't lose anything, because there's no to change something's velocity. If it's moving at 1,000 miles an hour, Newton's second law says you have to apply a force to change its velocity. So once it's got that 1,000 miles an hour velocity as a result of being on the surface of the Earth, it's going to stick it unless A, the pilot has something to change it, or B, there's some wind that moves it around. And if you move the wind and you assume the pilot's not going to move horizontally, just going to carry on going up, it's still going to retain that 1,000 miles an hour, no matter how high it goes. Now, what, as I say, will happen, if it goes up high enough, just like a car tire, you have to go faster around the edges. It will start to lose. It will not then come. If when it went up and came straight down, it wouldn't come back down in quite the same place. But it would have retained its 1,000 miles an hour throughout that process, unless affected by wind or other external factors.
Okay, so listen, just taking you up again on this elevation stuff.
Mm-hmm.
Is elevation right? So this is pretty much just a very standard question. Let's just get something concise sorted out here. Is elevation taken from mean sea level or the centre of the Earth?
It's not taken from either. It's taken from the WGS-84 spheroid. As I thought I'd explain. I've just spent.
I just wanted to get a concise. I just needed a concise one sentence.
No,
answer.
Neither. It's measured from the WGS-84 spheroid.
Okay, right. Now then, let's get back to Sleeping Warrior, who did his presentation. What did you think of that? Because essentially it was the same one that he did on Jose's.
That's right, which I did see, yes. I mean, it was... it's not quite the unadulterated idiocy that QE specialises in. He's got confused about gravity. Now, that's understandable for a flatty to get confused about gravity and this idea of a force and the bending of space-time, because it is slightly complicated, and it's not helped by Musa saying that gravity isn't a force and then moments later saying you have to treat it as a force. Also, Sleeping Warrior Anthony Wright doesn't understand what apparent is. Let's try and tackle where was that? So let's go back to the start of this. So for instance, gravity. Gravity, we talk about, and I've been guilty of this in the past. When you say gravity, what are you referring to? Now, are you referring to the force of gravity, or are you referring to the term gravity? So, for instance, if I talk to you about, we talked about electrostatic force between the proton and electrons. There is an electrostatic issue there, but we talk about the electrostatic force. So we're using electrostatic there as an adjective, as a prefix, and then saying it's that the subject of electrostatics is all about about charges, but there's the electrostatic force. Similarly with gravity. Now, gravity is actually now in modern terms, because Newton would just talk about the force of gravity. So Einstein then said, what is this gravity thing, the term gravity, what's that referring to? And that is correctly referred to by Einstein as the bending of space-time. It's the theory of the bending of space-time in this fourth dimension, which is something else that QE didn't understand. He only when I mentioned to him that it's 4D, was it last week, he suddenly discovered that space-time is four-dimensional. Apparently he's been pontificating about this, not realizing that space-time has 3 dimensions of space and 1 of time. It's four-dimensional. He's been pontificating about this for God knows how long, and he didn't know it was four-dimensional. I mean, this is the level of idiocy we're having to deal with here, guys. So in that 4D world that we can't really access because we can't move in the dimension of time. Because we don't perceive an ability to move through time. So therefore, we just regard it have a 3-dimensional world. And in the 4-dimensional world that Einstein proposed and has been experimentally verified, there is this bending of space-time, and I can show you the equations. which are incredibly complicated, and this is why we didn't work out what was going on. And so when Einstein refers to gravity, he's referring to the bending of space-time. Now, that manifests itself in our world as a force, and this is exactly what Musa said. He said that you have to treat it as a force in our world, but it originates. What he was trying to also say, it's not like that something reaches out, like the moon reaches out to the sun in a force. He made that particularly clear, which is what Newton was saying. So what it does is bends the space-time, and it's actually the curvature of space-time that actually is what the Earth feels, not a direct connection to the sun. It's the sun distorts the space-time, and the space-time then affects the movement of this. Because don't forget, in 4D space, even when you're stationary, you're moving along in a straight line in the 4D world. Even if you're stationary, you're charging along in this 4D world along the time dimension, even if you're stationary in this world. And gravity, the force of gravity, this is not gravity, the force of gravity, which is the thing you can independently verify by standing on some scales in your bathroom, because that is a force meter, and there's a force. So there's the experimental evidence for a force of gravity. But Einstein was saying this term, gravity, just like electrostatics, is an umbrella term, or to describe the theory of the bending of space-time, but the force of gravity is the thing that Newton uses. And in fact, Einstein said in that quote that actually Anthony, in his presentation, found at the end, where Einstein said, this theory that I've come up with in no way displaces Newton's theory. He totally approved of Newton, totally accepted Newton. And so some people might say, well, hold on, this 4D world that Einstein proposed, how do you know this is not just some mathematical thing? It's the line I think Anthony uses. How it's just maths, isn't it? No. It makes lots of testable predictions. For instance, the orbit of Mercury cannot be explained by Newton's laws alone. There is a modification, the general theory of relativity, is that the way the orbit precesses. In other words, it's an elliptical orbit and it rotates gradually, and Newton's laws do not account for this. General relativity does. So there's a prediction that it made, and exactly matches Newton's prediction. Similarly, when light leaves the surface of the Earth and goes upwards, it actually becomes more red, something else that Newton didn't predict, but general relativity does. Also, the change in time. If you have an atomic clock, you put it at the bottom of the Eiffel Tower and the top, you will find they'll be running at different speeds. That's predicted by Einstein's general theory of relativity, and we can test that. Similarly, gravity waves that have been found, they were predicted and found. There are about 10, also the bending of light, the ultimate test in 1919 by Arthur Eddington, that was the decider for everybody that general relativity was valid. It predicts that the bending of light would move twice as much than any Newton predicted, and of course so it matched and validated Einstein's thing. So there are about 10 independent tests that you can do, experiments and observations that can be conducted, that prove that Einstein's general relativity is a thing and it's not just maths.
Okay, right, so that was Sleeping Warrior's presentation, and we had the Analemma from Mr. 22, Brian 22. You only watched a little bit of that, but I actually really enjoyed that presentation, I have to say.
Well, I suppose... Sorry.
Yeah, I mean, I have to say, he purposely made sure that he revisited the original arguments that he put in. He did a presentation explaining how the globe model worked. He put a presentation in, well, how the globe model perceived the Analemma and how it would essentially work for the summertime and the wintertime and the temperatures and stuff like this. So he explained all that. And then he went
got it completely wrong. He got it completely and utterly wrong. What an idiot! Right, I think this is where we need.
Okay, well let me just finish what I thought. From what I saw of the presentation, this is how it came across to me. Was that I thought he put an awful lot of effort into it. He put a lot of work into it. He did an hour and 15-minute presentation, and I think I have to say, like I said, I really enjoyed it, and I thought it was. If you're going to say it's wrong.
It was unbelievable idiocy of the most extraordinary kind.
Okay, so what specific points
let's make
would
a
you say
point.
he was wrong?
Right, so this might need to share some screen here if you can share my screen again. Right, so Right. So let's say here's the Earth, and over here is the Sun. Whoops. Let's make this paint. Let's make this a bit. Hold on. Let's make this a bit smaller, and I'll zoom in instead. So there's the Sun. And of course, this Sun is an awfully long way away over here, so we can just model that. So we can just model this as light coming in like this, and up here we have it coming in here. Now, hopefully, let me make that a little bit darker. That's better. Right. So this is representing two light beams. Coming in. Right. So you should be able to see here that the area, now this has the same light rays here have the same density as each other, but you can see here that the area, or this is in 2 dimensions obviously, that the area, or the length of this line is about half, possibly even less than that, of this area here. And so you can see there's a factor of 2 or 3 in terms of the energy density of the light being received here than there is here. So this is getting 1/3 up here of the energy that this going down here. So it's going to be absolutely critical as to what, and then the axis, of course, of the Earth is something like this. Something like that. So if you're spinning around this point here, or this point, and you're on this point here, you can see that the energy density varies by a factor of about 3. And then this guy, I mean, this absolute idiot, he then said his basic argument was the distance. He was saying that there's a 4,000, or was it 4? Was it 4 million? Yeah, 4. Just make that into a small sensible size. He was saying, I think there was a 4 million kilometer. Let's make that variation between winter and summer, and that in the summer that we have, we are actually 4,000 meters. Well, we are in the northern hemisphere. We're 4,000 kilometers further away from the sun in summer. So he therefore said, well, okay, look, we're 4,000 kilometers further away in the summer. How do you account for the fact that it's warmer in the summer in the northern hemisphere? Right. Well, let's look. What is that as a proportion of the how much? What is it? Because the orbit of the Earth is. So if I go just away here, let's give that an outline. Right, so the orbit around the Earth, I'm exaggerating here, it's something like, oops, it's this sum, let's get rid of that outline. Right, let's make it a bit darker. Right, so, and it's at a focus of the ellipse there, say. So the distance here and the distance here, I've exaggerated it enormously. So his basic argument is we actually have summer in the northern hemisphere. Let's make this the Earth. There. And winter there. So and his argument was, look, hold on. The difference between these two is 4 million kilometers, and it's hotter when we're here than there. Oh, so therefore that invalidates that. I mean, he went on. He repeated the same point. I covered about 15 minutes, and that's the only point he made. And he thought that by repeating it about 79 times didn't invalidate. It somehow reinforced his point. What it reinforced was he's an absolute idiot. Right. So if you look at what proportion is 4,000 over the distance of the orbit of the Earth, it's effectively it was 4 million, but just gonna make sure I got the right is right. But what is the distance to the Earth in oh bloody hell, it's in what it is in kilometres. Damn it! Hold on. Let's see, going. Hold on. Let me just go and find out what the. I forgot. I can never remember it in kilometres. Is bloody yes, solid screen grabbing really slows everything down. Yes, 150, that's it. So it's 150 million, and you should be able to see from that that the profraction is 4 over 15. Oops, 4 over 15. Oh, Jesus Christ. So that's how much the have I got that right? Sorry, it's 4 over 150. Sorry, what am I talking about? So the fraction change in the orbit is absolutely tiny between these distances. Are absolutely tiny. Yet the factor due to the angle of the Earth is a factor of 3. So which do we think is going to be more important? The factor of 3. It's going to be the angle that matters, you moron. This little tiny variation is absolutely irrelevant. And this poor idiot went on and on and on and on for 15 minutes on this one invalid point. I was just intolerably idiocy, a torrent of idiocy, mixed up with graphics he didn't understand. He hadn't done any maths. He didn't understand about angles of incidence and the energy density. I mean, Jesus Christ. So his main point that he started off with, and the thing he emphasised repeatedly, just emphasised that he's a complete and utter idiot. Finished.
Okay. Right. Well, I think that's covered all 4 presentations this week. It's taken a little longer than I thought it would do. I wasn't quite prepared for you to sort of like go into the debunk of things, but that's all good. It's a bit new to the show. That's all cool. And I'm sure that whatever you presented here is going to be up for challenge at some point.
Of course, I don't mind
that. Right, going forward, we have 2 shows tomorrow, and then next week, for instance, next Monday, we have Paul on the plane, who will be doing a presentation. So I'm really looking forward to that. Really looking forward to seeing what he's got to present. So that'll be on Monday. Tomorrow we do have 2 presentations. I'll probably do a post in the morning explaining what they are and who they're from and what they'll be about. So I just need to clarify a few things before I actually publish that. Anything else? No, I think that's it. I think that's everything. Thanks for stopping by, Rumpus. You've taken up most of the show, which is cool. I had to do very little work. I just sat there and listened, basically. So made my job very easy, anyway.
Oh, I'm glad for that. If that's good, that's good. Excellent. I'm glad you approve.
Okay, right. Well, thanks everybody for stopping by. We've had about 120 people watching, which has been close to pretty average, really, for this Aftermath show, which is, it's not quite as popular, I don't think, as the main show. But ultimately, it's just basically a recap. So I suppose everybody's just sort of already listened to it and they've made their own opinions. But in any case, I think that'll do till tomorrow now. So I'm going to go and get a cold shower because it's absolutely boiling. I'm sat between 2 lamps that are shining on me to sort this green screen out behind me, and it's absolutely roasting right now. So anyway, thanks guys, thanks for stopping by, and I'll see you tomorrow, and I'll see you in the next one. Cheers.
Bye.